So welcome back. Now we're going to talk again about proof by induction, and again it's going to be an inequality proof. In this inequality proof we're going to look at factorial, so this is another kind of question they can ask. It's a little bit tricky, so we'd recommend knowing how to do this definitely. So I'll go through the question. So prove by induction that n factorial is greater than 2 to the power of n for n is greater than or equal to 4. Alright, so first thing I'll just talk about factorial. So if you guys are not sure what a factorial is, say you put a number before an exclamation mark, and that's called 5 factorial, and that's equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So just all the numbers going down to 1 just multiplied by each other. Alright, so that's how to write 5 factorial. So n factorial will be the same thing. It'll be all the numbers up until n. Okay, so it's a little bit different with the factorial, but it's still the exact same method. So we're going to start with step 1 as always. So step 1 is going to be prove true for the lowest number. So in this case the lowest number is going to be n is equal to 4. So that means we have to prove that 4 factorial is greater than 2 to the power of 4. So this is going to give us 24 is greater than 16. And there's a button on your calculator for factorial if you don't want to write 4 by 3 by 2 by 1 as well. Okay, so this is true. That's our first thing done. The second step now is we have to assume it's true for n is equal to k. Step 2, I'm going to write assume true for n is equal to k. So that means that k factorial is going to be greater than 2 to the power of k. So remember, we have to bear that in mind. We're going to use that later on. Now the third one, step 3, now we have to prove that it's true. Prove true for n is equal to k plus 1. Okay, this is where the maths comes in. So that means we're going to have k plus 1 factorial, so make sure you write it like that, k plus 1 all in a bracket, is greater than 2 to the power of k plus 1. So the trick here is how to write the k factorial or k plus 1 factorial in a different form. So if you think of k factorial, so write that here, k factorial is going to be 1 by 2 by 3 by all the way up to multiplied by k. Yeah, so I wrote it there 5 going backwards, but it can be the same. You can go from 1 all the way up to k. Alright, so that means k plus 1 factorial is going to be the same. So it's going to be 1 by 2 by 3 by everything all the way up to multiplied by k, and then it's going to be one number higher because k plus 1 is one number higher. So it's going to be multiplied by k, sorry, my bad, it's going to be all multiplied by k plus 1. It's going to be the last number. Alright, so we can use that to simplify this. So we're going to simplify this green here into, it's going to be k plus 1 multiplied by k factorial. Yeah, does that make sense? And now this as well I'm going to simplify into 2 multiplied by 2 to the power of k. So that's the same trick we did in the last video, and that's to do with indices. You take the plus 1, that'll change into a 2 multiplied by, and then you can write it in this form. Alright, so now we're going to take our piece of information from step 2. So I'm going to write step 2 here. Step 2. So we know that k factorial is greater than 2 to the power of k. So what I'm going to do is I'm going to sub 2 to the power of k in here for k factorial. So we're going to write then, oh, sorry, I glitched there for a second. So instead of k factorial, I'm going to write 2 to the power of k. So remember, you always sub in something from step 2. So we're going to have k plus 1 instead of k factorial again. We're going to have 2 to the power of k, and that's greater than 2 multiplied by 2 to the power of k. So again, that's the tricky bit that confuses people. But if we can prove that k plus 1 multiplied by 2 to the power of k is greater than 2 multiplied by 2 to the power of k, then we know that this above line is true. And why is that? It's because k factorial is greater than 2 to the power of k. So if you look at these two lines, they're the exact same, except this is smaller than that. So if this line is true, this line has to be true. Alright? So again, if you're not so sure about it, you can always just sub in whatever you have from step 2. So that's the trick. It's obviously better to understand it, but we'd prefer if you, it's obviously better to understand it, but if not, you can always just sub things in. Okay, so looking at this line here now, so I'm just going to put a quick box around it in dark blue. So this is definitely true, because if you look at it, you have k plus 1 multiplied by 2 to the power of k is greater than 2 multiplied by 2 to the power of k. So you can't cancel the 2 plus k's, But if you look at this number here, as long as k plus 1 is greater than 2, then this will be true. And k plus 1 is always greater than 2 because n is greater than 4. So that means, so I'll say this is true for k is greater than 4. So k and n are kind of the same thing. So since k is always greater than 4, k plus 1 will always be greater than 2. So that means we can say, therefore, that k plus 1 factorial is greater than 2 to the power of k plus 1. So you can go back and you can say the first thing is true. So that is a little bit kind of hard to look at. There's no definitive thing. I know you said normally you're not supposed to prove that one number is bigger than another, but in this case that's kind of the best way to do it. Alright? And this line here also means that it is, we'll say, true for n is equal to k plus 1. So now we have our step 3 proved, and now the last thing is to write our finishing sentence. So I'll go back up here and to the right. And we have step 4, it is true for all n is equal to k plus 1, assuming it is true for n is equal to k. And since it is true for n is equal to 4, it is true for all n is a natural number and n is greater than 4 as well. So I'll just write that in as well. And also that n is greater than or equal to 4. So that's that proof by induction done. The kind of tricky bit there is, well, one, this thing here, when you have to sub in step 2, if you can get your head around that, you're definitely halfway there. And then as well, this factorial thing, that k plus 1 factorial is equal to k plus 1 multiplied by k factorial. So that's the other kind of little trick in this question here. So that's it for the inequality induction proofs. It's the same method every single time. So again, if you're not totally sure on the say step 2 and getting the algebra, if you even write step 1, step 2, step 3, you're going to get most of the marks for that anyways. That's the important thing. So again, don't forget to like and subscribe if you enjoy the videos, tell your friends, and we'll see you next time where we're going to do a proof by induction we're going to do divisibility proofs, which is the next kind of proof by induction. So we'll see you then.